So now we're on to VodCast 10.3, and we are going to use the molar masses that we calculated in the last section to calculate some other things. So as we progress through this particular unit, everything is going to build on the previous VodCast. So you need to make sure that you are understanding the previous VodCast. Do not even attempt to go on until you've understood the previous VodCast. And if you're watching a whole bunch of these in a row, stop doing that. Do the worksheets, then come and do the VodCasts. Now, there may be one thing that you've noticed from the last particular worksheet, and that was at the top of that worksheet, there were these three terms. It says formula units, molecular weight, and molecular mass. Okay? But one of the things is all of these terms eventually mean the same thing. Okay? And so all of these terms are basically the way we calculate the molar masses of compounds. Okay? So one of the things is you just got to get used to the fact that these three terms are interchangeable, and for the most part, the term I typically use is molecular mass. Even though something might be a formula unit, okay, I typically drop the formula unit issue because molecular mass is just easier to say than formula unit. Okay, so now, let's say you have a new issue, okay? Let's say you have 3.5 grams of potassium nitrate, okay? And in those 3.5 grams of potassium nitrate, you want to find out how many molecules you have. And there you go right away. Potassium nitrate is a formula unit, and I'm going to use the word molecules, okay? Well, we need to plan this out, okay? I'm starting with grams, but in all of my conversions, I do not have a direct path to molecules. Okay, there is no way to go directly from grams to molecules. Okay, I can, however, go from grams to moles. Okay, what was the name of that number that allows me to go from grams to moles? And hopefully you are saying molar mass. Okay, and then once I get to moles, then I do have a way to get to molecules. Okay, so we have to make a plan. Okay, and we're going to start solving the world's problems, I like to say. Okay, and the world's problems is we got to have a plan. My plan is to go from grams to moles to molecules. And before you start doing problems, you want to figure out what am I starting with and where do I want to be. Okay? And so you need to stop and start thinking about how you're going to get there and do all those things. Okay? Well, as I said, if I'm going to go from grams to moles, okay, the number that I'm going to use is molar mass. Okay? And then if I'm going to go from moles to molecules, the number I'm going to use is Avogadro's number. And we're going to set this up in one big T box, okay? So to set this up in a T box, okay, I would have my grams of whatever compound it is, okay? And to go from grams to moles, I'm going to put my molar mass in this area right here, okay? Now, to use my molar mass here, I'm going to put 1 mole on top over however many grams there were for that particular compound. Okay, and remember, this is just a generic step-by-step process. Okay, because molar mass, if you remember unit-wise, is grams per mole. Okay, that's the unit of it. But down here, I want to cancel out grams, so I have to put the moles on top. And then Avogadro's number was 6.022 times 10 to the 23rd over 1 mole. Okay, so that's what I'm going to put in this last spot here is Avogadro's number. Okay, now, again, I'm going to have to take Avogadro's number, and I'm actually going to put it just like it has. I wrote it previously. It's going to be 6.022 times 10 to the 23rd all over 1 mole. And this way, now my moles cancel. So if you realize, all we are doing is conversion factors from a long time ago. And that's how we can go from grams to moles to molecules. So let's go back to our original problem. Okay, I have 3.5 grams of potassium nitrate. And hopefully you are getting better at writing formulas. And nitrate was one of the ones that I want you to memorize, so KNO3. Okay? And I want to take that grams to molecules. Well, I can't go directly to molecules, so I have to go to moles first, and then I'm going to go to molecules. So what I'm going to do is I'm going to follow that plan. Okay? To go from grams to moles, I'm going to use molar mass right here. And to go from moles to molecules, I'm going to use Avogadro's number. So basically, what I'm doing in this VodCast is taking VodCast 1 and VodCast 2 and putting it together to create VodCast 3. Wonderful. Okay? Now, I do have a little sidebar calculation I need to make. Okay? And that side calculation I need to make is I actually have to come up with what is the molar mass of potassium nitrate. So I got to break potassium nitrate down just like I did on the last worksheet where I have potassium. I have one of those, and that one potassium is 39 grams per mole. And I have a nitrogen, and I have one of those, and that's 14 grams per mole. And I have oxygen, and I have 3 of those, and that it would be, they're 16 grams per mole each. Okay, so 1 times 39 is 39, 1 times 14 is 14, and 3 times 16 is 48. So I will just add those 3 numbers up. And again, you should have a calculator handy at this point. And so that's 101 grams per mole, and that's my molar mass of potassium nitrate. Okay? So now, let me see if I can do this. Take this, I'm going to take this plan and pull it down here so I can move up here. So this is my plan that I want to take. Okay? I'm going to follow this plan. And so we're going to start my tea box with 3.5 grams of KNO3. In my first tea box, I'm going to put the molar mass, okay, which we just calculated right there. But I got to get it into this tea box correctly. I'm going to have to put 1 mole all over 101 grams, and that's of KNO3. Okay, and to do that, see, now my grams cancel. And then I'm going to do molecules, and that's Avogadro's number, 6.022 times 10 to the 23rd molecules per 1 mole. Okay, and now you do the calculation. Okay, so go ahead and pause the video and calculate. Okay, so I pulled up the calculator here just so you can see this. So you should be putting in 3.5, and then there's multiple ways you can do this. I like to divide by 101, okay? And then you can hit enter, okay? And then, according to the equation, we need to multiply by Avogadro's number, which is 6.022. Need to go to the exponent key, 23rd, and hit enter. And that should be what your calculator reads, is 2.08 times 10 to the 22nd molecules of KNO3. Okay, and this is the units that you should be writing. So now, I actually have a way to count atoms. Okay, remember we said we're counting atoms? If I mass something out, from that mass, I can count how many molecules I have, okay? So let's try another one. Let's say you have 0.035 grams of iron 3 nitrate. I want to know how many formula units I have. So there I set it correctly because I have an ionic compound here. Okay, so my plan. I have 0.035 grams of FeNO3. Okay, I want to find out how many formula units that is. I cannot go directly to formula units. I have to go from grams to moles, and then from moles, then I can go to formula units. So there's my plan. Okay, now, again, I need to do a sidebar calculation, side calc. Okay, and that side calculation is I need to know the molar mass of that. So again, I break the compound apart. I have Fe, I have 1 Fe, and that 1 Fe is 55.8 grams. And I have nitrogen. How many nitrogen have I got? I've got 3 of them. Okay, and those are each at 14 grams per mole. And then how many oxygen have I got in this critter? It's not 6. Okay, I have 9 oxygen in here, and if you're not sure why, ask me in class so you know. Okay, so 55 times 1 is 55, 14 times 3 is 42, and 9 times 16 is 144. So I'll add all of that up. 144 plus 42 plus 55.8, and that's 241.8 grams per mole. That would be the molar mass of iron nitrate. Okay, so again, I'm going to see if I can pull this down. Good, I can. Okay, and this is our plan. We want to take those grams to moles, so I'm going to set up my T-box. 0.035 grams FeNO3. And if you're one of those people that got this the first time I did it, okay, then you can probably fast forward right now. So I have 1 mole of FeNO3 per 241.8 grams. And then I'm going to use 6.022 times 10 to the 23rd formula units all over 1 mole. Okay, now again, crank out the math. Go ahead and pause the video if you need to, but you should do the math. And you should get 8.71 times 10 to the 19th. And that would be formula units of FeNO3. Okay? Now, if you want to fast forward, you can. I'm just going to show the math behind this. Okay, so calculator-wise, what you should have done is typed in 0.035, and you could have actually multiplied right here by 6.022 second exponent 23, and then you could divide by 241.8. and hit enter, and see you still get the same answer, 8.7 times 10 to the 19th. So how you put this in your calculator, as long as you're following the rules of mathematics, which you've learned in 5th grade, okay, you should be able to get these to work out. Okay, now let's change gears a little bit. What if I had a number of molecules of antimony 3 chloride and I wanted to know how many grams I had? Well, again, molecules does not go directly into grams. Okay, So I cannot go from here to here. Okay, that won't work. But I can go from molecules to moles. And then once I'm in moles, then I can go from moles to grams. So there is another path that you can take, okay? So in this particular case, now we're going from molecules to moles to grams. Well, what is the number that allows me to go from molecules to moles? And hopefully you are saying, well, that's Avogadro's number. Except this time with Avogadro's number, when I'm going from molecules to moles, I'm going to be looking for moles, so my moles is going to become on top. Okay? And then, once I'm at moles, I can go from moles to grams, and the number that allows me to do that is called, and I hope you are saying molar mass. But now with molar mass, this time, whatever grams I have are going to go over the 1 mole. So when I set this up into a tea box, now I'm starting with however many molecules. Okay, we don't care how many. I'm going to use Avogadro's number, 1 mole over 6.022 times 10 to the 23rd. And then I'm going to use whatever grams I have all over 1 mole. And you'll see that that cancels out my units. I should have wrote molecules here. So molecules cancel. And I end with the unit grams that I want. So really it's just a reverse process. Okay, so let's go back to the problem. I have 4.6 times 10 to the 23rd molecules of antimony 3 chloride. And so antimony is Sb. So you are writing SbCl3. And I want to know how many grams I had. So now we're going to make our plan. 4.6 times 10 to the 23rd molecules. And if you're paying attention, I really should have used the word formula units. I'm going to go from molecules, I'm going to go to moles, and then from moles, we'll go to grams. Now, because I need grams, I'm going to have to do my sidebar calculation. Okay, and my side calculation, again, is going to have to be the molar mass of antimony chloride. So, antimony, I have 1 of those, and its mass is 121.7. And I have chlorine, and I have 3 of those, and each chlorine is 35.5. So 121.7 times 1 is still 121.7, and 35.5 is times 3 is 106.5. So I'm going to add those 2 together. And I get 228.2 grams per mole as my molar mass. So, good, bad, or otherwise, one of the steps that you always have to do in these is you always have to calculate this molar mass. Okay, so let's bring my plan down here. Okay, and now that I have my plan down here in front of me, I'm going to set up my T box. So I have 4.6 times 10 to the 23rd molecules of SbCl3. I'm going to use Avogadro's number, so we'll put 1 mole all over 6.022 times 10 to the 23rd molecules. And then, now I have this molar mass that I just calculated, but I want the mass on top. So it's 228.2 grams per 1 mole. Okay, and now you just do the math. Okay, so if you want to go ahead and do the math, I'm going to pull up the calculator again, and I'm going to do the math on the calculator. So we'll type this in. We have 4.6 second exponent 23 divided by 6.022 second exponent 23 times, what was that molar mass again? Sorry, I gotta go back and get my molar mass. 228.2 times 228.2. So I get 174.3 grams. So I end with 174.3 grams of SbCl3. So as you can see, you can go from molecules to grams or from grams to molecules, okay? Here's another problem. If you want to see this again, go ahead and watch this. Okay, if you don't want to do another example, then fast forward to the next slide, okay? Because I'm going to run through this example, and I'm going to run through the whole thing. So you have 4.6 times 10 to the 23rd formula units of copper 1 chromate. So copper 1 chromate would be CuCrO4, but I believe chromate's a +2 or -2, so I think this is Cu2CrO4. I have to look now that I said that. Yep, chromate's a -2. Okay? So I need to convert those formula units to moles, and then moles to grams. Okay? Need to do my side calculation. Okay? This is going to be probably what you hate the most, because you always have to make this calculation. Okay, so copper, I have 2 of those. Each copper is 63.5 grams per mole. I have a chromium. I have 1 of those. That chromium is 51.9 grams. And notice again, I'm always using 1 decimal except for oxygen, which we said is always going to be 16. Okay, so I have my molar mass here of 2 times 63.5 is 127. 1 times 51 is 51.9. And 4 times 16 will be 64. So I'll add those up. And so that's 242.9 grams per mole. So I have my molar mass. Okay. Bring my plan down. I guess my plan has to come down in 2 parts this time. Okay. And we're going to rock and roll with the numbers. So oops. You notice what I just did there? That's kind of nice. And you really should be putting your units in here. Now do the math. And you would get 185.5 grams of copper 2 or copper 1 chromate. Okay. I'm going to skip ahead here. And one of the things I want to show you is it really doesn't matter. This is kind of a two-way street. Okay, if I started with grams, we went from grams to moles to molecular mass. to molecules, excuse me. We went from grams to moles to molecules. Okay? Well, so that's if I started over here with grams. I went that direction. Okay? Well, if I start over here with molecules, okay, I'm just going to go the other direction. Okay? So some people usually just use this path and just go back and forth between it. Now, the one thing with this is you have to pay attention to what the questions are asking, because sometimes questions might say, how many, if I start with a number of grams, how many moles do I have? Okay, well, now you're just going from grams to moles and you want to stop. Okay, so you can stop in this street anywhere you want. It's just a path. You just always have to pay attention to what the questions are asking. Some questions might say, well, you have X number of molecules. Okay, well, how many moles have you got? Okay, well, now you're going to go from molecules to moles, and you're going to stop. You're not going to go all the way to grams. So always pay attention to what your questions are asking, okay? So now you should be able to complete the next worksheet. That would be your assignment.